Right now, beneath one of the most closely watched volcanoes in the United States, the Earth is making small sounds again. They are not the kind of shocks that knock dishes off shelves. They are not the kind of blasts that paint the sky black. Most people living hundreds of miles away would never feel them, and if you only glanced at the numbers, you might even dismiss them as too small to matter. But that is exactly why scientists pay attention. Because at volcanoes like Mount St. Helens, the biggest story often begins with the smallest movements, tiny earthquakes, quiet shifts in pressure. Signals so subtle that the mountain can look calm to everyone standing outside it, while deep below the surface, something important is changing. And that is why Mount St. Helens is back in the conversation again. If you hear that phrase and your mind jumps immediately to another catastrophic eruption, you are not alone. Mount St. Helens occupies a special place in the American imagination because it is not just a mountain. It is a reminder that landscapes that seem permanent can change suddenly, violently, and on a scale that permanently rewrites how a region sees itself. It is one of those names that carries memory inside it, and when a mountain like that starts shaking again, even quietly, fear returns faster than context. Rumor moves faster than data. A few clips, a few headlines, a few dramatic posts, and suddenly people are asking the same question all over again. Is it waking up? That question sounds simple, but the real answer is more unsettling and more interesting than a plain yes or no. Because Mount St. Helens is not dead. It was never dead. It is an active volcanic system, and active volcanic systems do not need to be erupting to be changing. They breathe in geological time. They pressurize, cool, crack, recharge, adjust, and sometimes do that for years without a dramatic surface event. So when scientists say the volcano is showing activity, that does not automatically mean an eruption is imminent, but it also does not mean nothing is happening. The truth lives in the difference between those two extremes. And by the end of this video, that is exactly what you're going to understand. What the new shaking means, why scientists are watching closely, what signs are still missing, and why the real danger at Mount St. Helens is not just whether it erupts, but whether the public confuses background unrest with the kind of unrest that actually changes the risk. What makes this moment so compelling is that the mountain is active enough to attract serious scientific attention, yet not active enough to justify panic. That middle zone is where misunderstanding thrives. It is also where the best science stories live, because when a volcano is fully erupting, everyone can see the danger. The ash is visible, the plume is visible, the lava dome growth, the explosions, the closures, the aviation alerts, the emergency bulletins, those are obvious. But long before any of that, there is a quieter phase when specialists look at instruments and ask a much more difficult question. Is this just the volcano being itself, or is this the beginning of something larger? The current answer from the U.S. Geological Survey is clear on one critical point. Mount St. Helens is at volcano alert level normal and aviation color code green. In an official information statement published by USGS on September 16, 2025, the agency stressed that even when strong winds lifted old volcanic ash deposited during the 1980 eruptions, there was no eruption in progress and no change in alert level. That matters because it shows how easily dramatic visuals can be misread. A plume in the sky does not always mean fresh magma is rising. Sometimes it means old ash has simply been picked up by weather. Sometimes what looks alarming is not the actual danger. That lesson matters now more than ever, because at Mount St. Helens, the hardest part is not seeing a dramatic image. The hardest part is understanding the invisible signals beneath the crater floor. And those signals are real. On the Pacific Northwest Seismic Network's Mount St. Helens monitoring page, the last 30 days of recent events show many tiny earthquakes located near the volcano in July 2026, with magnitudes often around 0 to 1 and many of them clustered at depths of several miles. That pattern by itself does not tell us an eruption is coming tomorrow, but it does tell us the system is not asleep in the way most people use that word. A volcano does not need headline-sized earthquakes to be restless. In fact, at volcanoes, the small repetitive ones are often more informative because they can reveal pressure changes, cracking rock, or fluid movement in very specific parts of the system. If you want the broader context, the USGS already gave it. In a detailed scientific update about Mount St. Helens seismicity, the agency said that since February 1st, 2024, approximately 350 earthquakes had been located at the volcano by the Pacific Northwest Seismic Network. More than 95% of those earthquakes were below magnitude 1.0, too small to be felt at the surface. The weekly rate peaked in early June 2024 at 38 events per week. The largest was only magnitude 2.0. The median depth was about 3.5 miles below sea level, or roughly 4.6 miles below the crater floor. Then comes the part that should make every serious viewer stop and pay attention. USGS said short-term increases in earthquake rates are common at Mount St. Helens and are considered part of background seismicity, but these increases can also reflect pressurization of the magma transport system, potentially caused by recharge. In other words, the mountain can produce lots of tiny earthquakes without being on the edge of eruption, and those earthquakes can still be evidence that magma is gradually re-entering parts of the plumbing system. That is where this story becomes far more fascinating than the usual viral headline, because the scary phrase is not actually eruption. The scientifically important phrase is recharge. Recharge means the magmatic system is being supplied again. USGS explains that Mount St. Helens is fed by magma that forms near the base of the crust at depths of about 16 miles. That magma slowly rises through the lower crust and accumulates in a reservoir located roughly 2.5 to 6 miles below sea level. When new magma enters this upper reservoir, stresses can increase enough to trigger earthquakes. So when people hear that Mount St. Helens is shaking, what that may mean is not that magma is already racing toward the surface, but that deeper parts of the system are being pressurized again. It is the difference between hearing footsteps in the basement and hearing the front door slam open. Both mean someone is in the house. Only one means they are already in the room with you. And this is where the story gets even more important because recharge can last a long time. USGS specifically notes that high rates of seismicity interpreted as recharge have been observed in the past at Mount St. Helens and at other volcanoes and can continue for many years without an eruption. That line changes everything. It destroys the lazy assumption that any cluster of quakes means immediate catastrophe. But it also destroys the opposite assumption that because nothing dramatic has happened yet, the current activity is meaningless. Recharge is the kind of process that teaches humility. It reminds us that volcanoes do not work on our emotional schedule. They do not care that headlines burn out in 48 hours. They do not care that social media wants a clean ending. A volcanic system can be preparing, reorganizing, and pressurizing on timescales that are frustratingly slow for the public and incredibly important for scientists. That is why comparisons to older swarms matter. In a USGS piece on a previous Mount St. Helens swarm, scientists described how small earthquakes in 2016 and again in 2017 did not indicate future eruptive activity. After winter storm damage temporarily reduced the seismic network, repairs in April 2017 allowed researchers to see that a small swarm had already been underway. By May 5, 2017, the Pacific Northwest Seismic Network had located 47 earthquakes since the network was restored. And by using repeating characteristics, scientists could detect well over 100 events that were part of the same swarm. Most were between sea level and about 3 miles below sea level. Rates were only about one earthquake every few hours. Most magnitudes were below 1.5. The maximum was just 1.3, and there was no detectable deformation or gas signal. USGS concluded that the swarm was very unlikely to be a precursor to imminent eruptive activity because it resembled earlier swarms, consisted of very small earthquakes occurring at low rates, and lacked the other geophysical indicators that usually matter far more. That history is not just a technical footnote. It is the key to reading the present correctly. Mount St. Helens has a pattern. It can produce swarms. It can signal recharge. It can remind the world that magma is still part of the system. And yet, the mountain can do all of that without crossing the threshold into eruption. If you stop listening there, you might feel relieved. But you should not get comfortable yet, because the deeper lesson is not that the mountain is harmless. The deeper lesson is that it has multiple modes of unrest, and only some of them are truly dangerous in the short term. Knowing the difference is what separates dramatic storytelling from responsible analysis. So, what would a more dangerous shift actually look like? To answer that, it helps to look at a period when Mount St. Helens did move beyond deep background unrest and into a new eruptive phase. USGS describes the onset of the 2004 to 2008 renewed activity in unusually concrete detail. In the early hours of September 23, 2004, a swarm of small magnitude earthquakes began beneath the old lava dome, but these were shallow, less than about 1 kilometer below the surface. Over the next 7 days, earthquake frequency and size increased, and a growing welt formed on the southeast margin of the old dome and nearby parts of Crater Glacier. By September 26th, scientists were already warning of an increased chance of explosions. On October 1st, the volcano produced the first of several explosions, sending ash and gas into the atmosphere. Then on October 11th, hot solid lava spines began puncturing the surface, initiating a new dome-building phase. Read that sequence carefully because it tells you what real escalation looks like. The earthquakes were not just present, they became shallower. The rate increased, the size increased, surface deformation became visible, a physical bulge developed, explosions followed. That is a completely different pattern from a volcano simply registering deep, tiny events beneath the system while deformation, gas emissions, and thermal signals remain stable. This is the part of the story the audience needs most because public fear often begins with one true fact and then ignores the scale, depth, and context that give that fact meaning. Yes, Mount St. Helens is active. Yes, it is shaking. But no, the current picture is not the same as the beginning of the 2004 eruption, and it is certainly not enough, on its own, to justify claims that a major blast is imminent. At the same time, dismissing the current activity would be just as irresponsible. The mountain is not finished. USGS says plainly that the 2023 and 2024 periods of elevated seismicity represented the largest short-term increase in earthquake rates since the last eruption ended in 2008. That does not mean the next step is eruption. It means the system remains capable of producing significant unrest, and the reason scientists can sound calm while still paying close attention is not because they are unconcerned. It is because they know exactly which indicators have and have not changed. That brings us to the most important question in this entire story. What are the warning signs that would make the current situation look very different? The first would be a clear upward migration of earthquakes, where the shaking begins deeper and starts moving progressively closer to the surface. Deep earthquakes can indicate pressure changes in the plumbing system. But when a sequence becomes shallower over time, that is when scientists start asking whether magma or fluids are moving into positions that can directly affect the surface. The second warning sign would be the appearance of volcanic tremor or more persistent long-period seismic signals, rather than just brittle cracking events. Now, that kind of signal can suggest sustained fluid movement. The third would be inflation, actual swelling of the ground as pressure builds. The fourth would be changes in gas, especially increases in emissions that suggest magma is degassing more aggressively at shallow levels. And the fifth would be obvious shallow steam-driven explosions or newly intensified thermal activity. In past USGS assessments of recent swarms, one of the strongest reasons for confidence that an eruption was not imminent was the absence of exactly these kinds of accompanying signals. In other words, the real story right now is not simply that Mount St. Helens is making noise. The real story is that it is making one kind of noise, while not yet making several others. That might sound less exciting than a simple apocalypse headline, but in reality it is far more suspenseful, because it places the mountain in a scientifically meaningful middle state. A state of recharge, a state of attention, a state where the system is active enough to matter and calm enough to resist simplistic conclusions. And there is another reason this topic is exploding across the current YouTube landscape. It combines three things that almost always perform well when they appear together: a famous location with an unforgettable history, fresh instrument-based activity that feels current, and uncertainty. That last element is the most powerful. If scientists declared that everything was routine forever, the story would die. If scientists declared that an eruption was imminent, the story would become emergency coverage. But when the truth is that something is happening, and experts are carefully distinguishing between recharge and eruption, audiences lean in. Uncertainty is sticky. It creates a reason to keep watching, a reason to keep checking, and a reason to hear the full explanation rather than stopping at the first frightening sentence. That is also why Mount St. Helens fits GeoPlanet's audience so well. This channel performs best when a story lives at the intersection of fresh evidence, human consequence, and Earth system explanation. We saw that in the Antarctica warning video, where long-term change was framed as a countdown but grounded in named scientific sources. We saw it in the Texas earthquake documentary, where the title offered mystery, but the script earned trust by carefully laying out the evidence and the uncertainty. Mount St. Helens gives us all of that in one story. A volcano people already fear, new seismic activity people can point to right now, official monitoring data that both warns and reassures, and a deeper scientific lesson about how active systems behave long before the public sees smoke. There's a psychological trap here that affects almost everyone. People think danger must look dramatic while safety must look quiet. But in volcanology, the situation is often more deceptive than that. A mountain can look majestic and still be building pressure. A dramatic ash cloud can turn out to be wind lifting old deposits rather than a new eruption. A swarm of tiny earthquakes can be more informative than one bigger quake. What matters is not how frightening the image is. What matters is whether multiple independent monitoring signals begin telling the same story at the same time. That is why the USGS monitoring language deserves attention. In the 2024 seismicity update, the agency emphasized that despite the elevated earthquake activity, there had been no significant changes in ground deformation, volcanic gas, or thermal emissions, and no change in hazards at Mount St. Helens as a result of the activity. That sentence is more important than a dramatic thumbnail, because volcano monitoring is a discipline of convergence. Scientists become concerned when separate systems begin lining up: seismicity, deformation, gas, heat, surface change, visual observations. If one signal rises while the others remain stable, that often argues for caution rather than alarm. The instruments are not just measuring movement, they are cross-examining one another, and yet even a calm statement like that should not be misunderstood as a guarantee. Volcanoes are not machines that announce every move with equal clarity. The 2004 to 2008 eruption itself is a reminder of that. USGS notes that the 2004 event began with a shallow swarm and clear escalation, but even during that eruptive phase, significant explosions in January and March 2005 had no recognizable strong precursors. One January explosion happened at the start of a winter storm and destroyed instruments in the crater. Another in March was preceded only by a very subtle increase in seismicity a few hours beforehand. That does not mean scientists were blind. It means nature does not always cooperate with the neat timelines people expect. Monitoring greatly improves warning, but it does not turn a volcano into a scripted event. This is where the public conversation usually fails. It swings from overconfidence to overreaction and then back again. If the mountain is not erupting today, some people conclude there is no story. If the mountain shows even a modest swarm, others conclude catastrophe is inevitable. Both instincts are wrong. The mature view is that Mount St. Helens is a dynamic system that has been producing deeper unrest for years, that this unrest likely reflects pressure and recharge within the magmatic system, and that scientists watch these changes precisely because they know how important it is to recognize the moment when a familiar pattern stops being familiar. And there is one more crucial distinction the audience needs to understand. Not every future eruption at Mount St. Helens would necessarily resemble the event most people imagine. The 2004 to 2008 activity was very different from the iconic catastrophe people associate with the volcano. USGS explains that the new dome during that period grew by continuous extrusion of degas lava spines that had mostly solidified below the surface, rather than by the same style of lava effusion seen in the 1980s dome building period. The renewed eruption was notable for its lack of major explosive behavior, compared with what people fear when they hear the mountain's name. That matters because it means that even if the system re-enters a more active surface phase someday, the exact style, pace, and hazard profile would still depend on the specific processes involved. In other words, the future is not automatically a replay of the most famous disaster. But that uncertainty cuts both ways. The fact that not every eruption would be catastrophic does not mean future activity can be shrugged off. It means that what happens next would depend on where pressure accumulates, how fast magma rises, how much gas remains in the system, whether pathways open, whether deformation accelerates, and whether the seismic pattern changes character. Which brings us back to the central truth of this video. The present seismicity matters because it is part of the ongoing life of the volcano, but the missing signals matter just as much because they tell us what has not happened yet. Think about how unusual that is from a storytelling point of view. Most viral stories are built around a single dramatic reveal. This one is built around a contradiction. The volcano is active, but not escalating in the most dangerous way scientists look for. It is recharging, but not obviously on an eruptive countdown. The ground is shaking, but the mountain remains at normal and green. That contradiction is not a weakness in the story. It is the entire story. It is why viewers stay to the end, because the tension is not resolved by one frightening clip. It is resolved by understanding what the instruments are actually saying. So let's translate the science into the simplest possible image. Imagine Mount St. Helens as a tall building with multiple floors and a complicated plumbing system hidden in the walls. Right now, scientists are hearing noises from deeper inside that building. Pipes are pinging. Pressure is shifting. Something is moving in places the public cannot see, but the smoke alarms are not sounding. The walls are not bulging outward. The temperature at the top of the building is not suddenly spiking. And no one has seen flames breaking through the roof. That does not mean you ignore the noises. It means you do not tell everyone the building is already on fire. This is also why the current trend of videos about Mount St. Helens keeps multiplying. It is not only about fear, it is about interpretive advantage. Every channel wants to answer the question first. Is the mountain waking up? Is the shaking serious? Are scientists worried? But the channels that actually win long-term trust are the ones that go one level deeper and explain what scientists mean when they use cautious language. Because scientific caution does not mean indifference. It means the people closest to the data know how dangerous it is to overread one signal in isolation. And make no mistake, Mount St. Helens remains one of the most intensively monitored volcanic systems in the country for a reason. USGS says it jointly operates the monitoring network with the Pacific Northwest Seismic Network and continues to watch the volcano closely. That is not a ceremonial statement. It reflects a sustained institutional memory. Earthquakes, deformation, gas, satellites, webcams, fieldwork, repeated analysis, and constant comparison with past patterns. The public sees a mountain. The monitoring teams see a living system with a documented behavior history stretching across decades. That history tells us something else worth remembering. Even when elevated seismicity does not lead directly to eruption, it still teaches scientists about the volcano's internal architecture. Repeating earthquakes can show that events are occurring in close proximity. Depth ranges can help constrain where stress is accumulating. Changes in rate can help distinguish ordinary background activity from more unusual episodes. Every swarm becomes part of the mountain's biography. Every non-eruptive episode improves the baseline against which future unrest will be judged. So even if this current period ends quietly, it is not a false alarm. It is data. And at dangerous volcanoes, better data is never wasted. That may sound less cinematic than the internet's loudest claims, but in reality, it should make the mountain feel even more real to you. Because the most unsettling thing about Mount St. Helens is not that it can erupt. We already know that. The unsettling thing is that it spends long periods doing things that only specialists fully understand, and those subtle periods are exactly when the future is being shaped. The public tends to notice the mountain only when it becomes visually dramatic. Scientists pay attention long before that because they know the real question is not whether the volcano can produce awe. It is whether the system is crossing from background unrest into a new phase of shallow, escalating instability. Right now, the evidence says it has not crossed that line. The recent earthquake activity fits a pattern of deep unrest and recharge, rather than a clear, immediate, pre-eruptive sequence. The official alert level remains normal. The aviation code remains green. USGS has said there have been no significant accompanying changes in deformation, gas, or thermal emissions. Previous similar swarms did not lead to eruption. Those are the facts. But the story does not end with reassurance because the same official sources also make it clear that Mount St. Helens remains active, that elevated seismicity since 2023 and 2024 has been significant in context, and that recharge can continue for long periods before anything visible happens at the surface. Those are facts too. And that is why this volcano will keep drawing attention. Not because every week brings a disaster, but because it does not. Because a mountain with this history can sit in a scientifically meaningful gray zone where each new signal matters. Because people want certainty, and the mountain offers only process. Because the most honest answer to the question, is it waking up, is this. It never truly went to sleep, but the kind of waking that leads to real short-term danger is defined by a pattern we are not seeing in full right now. If you have stayed with me this far, then you already understand more than most people scrolling past the headline. You understand why the small earthquakes matter. You understand why recharge is not the same thing as eruption. You understand why scientists compare the present not only to the volcano's most violent moments, but also to its quieter swarms, its deeper pressure changes, and the very specific signal combinations that would force a different conclusion. And you understand the most important principle of all. With a volcano like Mount St. Helens, the absence of panic should never be mistaken for the absence of change. So here is the final thought I want to leave you with. Mount St. Helens is not just a symbol of past destruction. It is a live lesson in how the Earth communicates. Quietly at first, indirectly at first, through tiny earthquakes, subtle patterns, and long stretches where the drama lives in what instruments detect rather than what the eye can see. The mountain is shaking again. That part is true. But the deeper truth is that the real warning sign scientists are waiting for is still something else. The moment when the shaking becomes shallower, the ground begins to deform, the gases change, the thermal picture shifts, and multiple systems start telling the same story. If that day comes, the meaning of these small earthquakes will look very different in hindsight. Until then, the smartest response is neither panic nor apathy. It is disciplined attention. It is following the people who measure before they speculate. It is understanding that a green alert does not mean a dead mountain, and a deep swarm does not mean a countdown has reached zero. It means Mount St. Helens is reminding us that it is still alive below the surface, still connected to magma rising from deep in the crust, still capable of change, and still important enough that every small signal deserves to be read carefully. In the end, that may be the most unsettling part of all. Not that the volcano is erupting now, but that it does not need to erupt for the story to matter already.